Hey everyone, welcome to Unit 2, Lesson 3, Image Compression. Yeah, so the objectives of this unit is I will know how a computer compresses images, and I can know what the run length encoding, or RLE compression algorithm is, and I will be able to explain the need to compress images. Right. So, how do computers store images in the first place? How do computers store most anything at all? Yeah. Computers store images like they store almost everything else in binary bits. Yeah, bitmaps are a way for computers to store images that have two colors, right? Like this particular image here is a bitmap. So bitmaps are a way for computers to store images that have two colors. A computer remembers that an image on, like for example, the image on the right, it saves a 1 for red pixels and a 0 for white pixels. Now, bitmaps aren't the most complicated of images, but yeah, they're not the most complicated of images, but they're like low quality icons. They're good for icons and stuff. So computers can save images in other more complex ways, other than bitmaps. They can use like 3 numbers for each pixel, for example, instead of simply like a 2-color image or whatever. But for our current example, we're gonna undersimplify things, and then we'll look at more complex. So for example, they use bitmaps. Just remember 1 for one color and 0 for the other color. For example, the third row, this one here, can be saved in a bitmap as 0 because it's a white pixel, and then 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0, 0. This binary string here. And if you noticed how you could compress this, if you were telling this to someone, like the way I read it off, you would compress it as like 1, 1, or 1, 0, and then 6 ones, 1, 0, 6 more ones, and 2 zeros. What you just did there is what we call run length encoding, which run length encoding is a lossless compression technique, which means you can compress and uncompress and recompress whenever you'd like, and you won't lose any data. Yeah, it's pretty lossless. We covered lossless in the first lesson in this unit. Yeah. So RLE compression algorithm. Now let's look at what this RLE compression algorithm really does. So in run length encoding, or RLE, the computer replaces each row of a bitmap with numbers that say how many consecutive pixels are the same color, always starting with the number of white pixels because it's easier to start with zeros. So it finds usually most of these compression algorithms, as we found, they look for things that repeat, and then they replace them with how many times they see these repeating things. If you think back to text compression from last episode, it's really similar to do that way. For example, in that first row of that heart, no. Yes, in this first row there were 3 white pixels, 2 red pixels, 5 white pixels, 2 red pixels, and 4 white pixels. 4 white pixels. Yeah, 4 white pixels. Or this way is how we represented it over there. This essentially, once we run it through run length encoding, it will spit out, instead of saving all these numbers here, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, it can just save 3, 2, 5, 2, and 4, which is a much smaller memory usage string than all these zeros and ones here. And remember, this is a lossless form of compression, so it can definitely be undone and redone if you need it to be. Yeah, RLE decompression and uses. So how do we decrypt some of these RLE? Well, to decode so to decode run length encoding, or RLE, the computer simply replaces each of the numbers with rows of a bitmap starting with the numbers of white pixels. So it saves the rows from top to bottom, and then it renders the image. For example, the first row of this mystery image below, which, I don't know, it's probably not a mystery anymore. But the first example of this mystery image below, the first row is 4 9s 3, right? So 4 white pixels, 1, 2, 3, 4. 9 black pixels, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3 white pixels over here, which are off screen. And remember, this is a lossless form of compression, so it can be undone. And yeah, so here's the mystery image. A good activity would be try and pause the video and try to see if you can draw out the mystery image. Remember that they always start with white pixels, so 4 white pixels. Here's the first row. And then pause the video and see if you can do it. And here's the answer. Here's the answer. It's a nice teacup there. So you see 4 white pixels, 9 black pixels, 3 white pixels, 4 white pixels, 7 black pixels, 2 white pixels, a black pixel, 2 white pixels. And you can kind of see like more correlations here and here. Yeah, so like this one has 0 white pixels and then 15 black pixels and a white pixel. And remember, these always start with white pixels. Conclusion. So today we talked about image compression. So what is image compression? Well, it's the ability of a computer to compress an image. How does RLE compression work? Well, RLE compression finds repeated patterns and saves space by, instead of writing out all the zeros and ones, just remembering how many zeros and ones there are, and just remembering that it's white, black, white, black, white, black. What compression method is this? So it is a lossless version of compression, because again, it can be recoded and decoded, or compressed and decompressed relatively quickly, and all at the same time. Thank you for coming to this class. Tell me if you like this new format. Yeah. Hope it's, well, have a nice day.